Imagine Earth stripped bare, no swirling clouds, no vibrant sunsets, just a stark, silent sphere against the blackness of space. This, my friends, is Earth without its atmosphere, a lifeless rock exposed to the universe's harsh realities. Now picture our planet as it is. A vibrant blue marble, swirls of white clouds dance across its surface. Continents painted in greens and browns peek through. This is Earth as we know it. A planet teeming with life, all thanks to a delicate, invisible shield, the atmosphere. The atmosphere is our planet's breath. It's the very air we breathe. It's the shield that protects us from the sun's relentless radiation. It's the reason our skies are blue and sunsets ablaze with color. Without it, silence. With it, the symphony of life. Join me now as we explore this remarkable envelope of gas that makes Earth, well, Earth. Imagine stepping into a glass elevator. Your destination, the edge of space. As we ascend, we journey through the distinct layers of our atmosphere. Our first stop is the troposphere, the layer closest to Earth. This is where weather happens. Clouds form, rain falls, birds soar. It's a bustling hub of atmospheric activity. Next, we reach the stratosphere. Here, the air thins, temperatures rise. This layer is home to the ozone layer, our shield against harmful ultraviolet radiation. Jet planes often cruise in the lower stratosphere, above the turbulence of the troposphere. As we continue upward, we enter the mesosphere. Temperatures plummet in this layer. It's here that most meteors burn up upon entry, creating fiery streaks across the night sky. The thermosphere is our next stop. Temperatures soar once again, reaching thousands of degrees. However, the air is so thin that it wouldn't feel hot to us. This layer is where the aurora borealis, the northern lights, shimmers and dances. Finally, we reach the exosphere, the outermost layer of the atmosphere. Here, the air gradually fades into the vacuum of space. This is the boundary between Earth and the vast cosmos beyond. We often use the terms weather and climate interchangeably, but they are distinct phenomena. Think of it this way. Weather is your mood, climate is your personality. Weather is what's happening in the atmosphere right now. Is it sunny, rainy, windy? Weather is constantly changing. It's what you see when you look out the window each day. Climate, on the other hand, is the long-term average of weather patterns in a particular region. It's shaped by factors like latitude, altitude, and proximity to oceans. Climate tells us whether a region is typically hot or cold, wet or dry. For example, a place like London is known for its temperate, rainy climate. This doesn't mean it rains every day in London. But over the long term, London experiences more cloudy, rainy days than a desert region. Understanding the difference between weather and climate is crucial for comprehending the complex workings of our planet. The sun is Earth's ultimate energy source. Its radiant energy bathes our planet, driving weather patterns and shaping climates. But the sun's energy isn't distributed evenly across Earth's surface. This uneven heating is what creates distinct climate zones. Regions near the equator receive the most direct sunlight. The sun's rays hit these areas at a near perpendicular angle, concentrating the energy. This is why equatorial regions are generally hot and humid. As we move towards the poles, the sun's rays hit Earth at increasingly oblique angles. This spreads the energy over a larger area, resulting in less heating. This explains why polar regions are significantly colder than the tropics. The tilt of Earth's axis also plays a role in climate variations. During summer in a hemisphere, that hemisphere is tilted towards the sun, receiving more direct sunlight. During winter, the opposite occurs. This axial tilt is what gives us our distinct seasons. Section 5. The atmosphere in motion: winds, rains, and monsoons. The uneven heating of Earth's surface sets the atmosphere in motion, creating winds, rain, and complex weather patterns. Warm air, being less dense, rises, while cooler air sinks to replace it. This continuous cycle of rising and sinking air drives global wind patterns. Trade winds, for example, blow steadily towards the equator from the northeast and southeast. These winds played a crucial role in early ocean navigation. High above, jet streams, fast-flowing air currents zip around the globe, influencing weather systems. The water cycle is intricately linked to atmospheric circulation. Heat from the sun evaporates water from oceans, lakes, and rivers. This water vapor rises, cools, and condenses into clouds. When the water droplets in clouds become heavy enough, they fall back to Earth as precipitation, rain, snow, or hail. Monsoons, seasonal wind patterns that bring heavy rainfall to certain regions, are another example of the atmosphere's dynamic nature. These winds reverse direction with the seasons, driven by temperature differences between land and ocean. Section 6. El Niño and La Niña, the Pacific Ocean's dramatic duo. In the vast expanse of the Pacific Ocean, a fascinating climatic dance unfolds: El Niño and La Niña. These periodic climate patterns, collectively known as the El Niño Southern Oscillation or ENSO, have far-reaching effects on weather patterns around the globe. El Niño, characterized by unusually warm surface waters in the central and eastern Pacific, disrupts normal weather patterns. It can lead to increased rainfall and flooding in some regions, while causing droughts in others. La Niña, El Niño's cooler counterpart, brings colder than average sea surface temperatures to the same region. La Niña events can intensify Pacific hurricane seasons and influence winter weather patterns in North America. Understanding El Niño and La Niña is crucial for predicting and mitigating their potential impacts on agriculture, water resources, and ecosystems. Section 7. Earth's Protective Veil, a recap of atmosphere and climate. From the air we breathe to the weather we experience, the atmosphere is an integral part of our planet. It's a dynamic system driven by solar energy and Earth's rotation. We journeyed through the atmospheric layers, from the bustling troposphere to the edge of space in the exosphere. We learned how the uneven heating of Earth's surface creates winds, rain, and distinct climate zones. And we explored the dramatic interplay of El Niño and La Niña in the Pacific Ocean. The atmosphere is a delicate balance, a complex web of interconnected processes. Understanding this intricate system is crucial as we face the challenges of a changing climate. Section 8. Delving deeper. a glimpse into the hydrosphere and ocean currents. Our exploration of Earth's interconnected systems doesn't end here. In our next adventure, we'll dive into the vast realm of the hydrosphere, the totality of Earth's water. We'll explore the powerful forces that drive ocean currents, from the Gulf Stream's warming embrace to the icy grip of the Antarctic circumpolar current. Join me as we unravel the mysteries of the deep and discover how the oceans shape our planet's climate and support a dazzling array of life.
Like, share, subscribe, and press the bell icon for more updates. Keep learning, keep vibing.